All right, this is Mr. Wyrick, and today I'm going to go through these 433 spherical geometry notes for you. This is not going to be notes for the 4th of May. It's going to be for the 1st of May. So what's spherical geometry? This is spherical geometry. It's shapes made on spheres. It's how we do calculations of distance on the globe so that we know we're traveling. We're not actually traveling in a straight line. We're traveling on something curved. We got 3 different points that we're using to triangulate distance. GPS satellites work kind of like with this stuff too. So one of the important things to remember, what do we need to know? All straight lines are made by great circles. Okay, so all of the longitude markings on the globe, like those, work. The latitude ones, as they get smaller, going up and up and up the circle, they don't work. Okay, so the lines in true spherical geometry would not include most of those lines of latitude, with the exception of the equator. It has to be a great circle. Okay, now we can angle those all we want, but that's just how it works. Any shape that we form is not going to have the standard number of degrees in the angles. Triangles can have more than 180 degrees. So you can see this is a 90-degree angle here, but you can tell this right here, going between line A and line C here, like this is not an acute angle. And this over here, well, I mean, they're acute angles, but they're not small little bitty angles, okay? In fact, if you were to do this right here, take this point C and make it like the North Pole and have 90 degrees between the different lines that you're putting there, they would come down and intersect the equator, and where they intersected the equator, those would also be 90-degree angles. So you could have 3 90-degree angles in that triangle. Okay, and it would be perfectly fine. You could go bigger, you could go smaller, depending on how you kind of set these up. But you don't have to stop at 180 degrees anymore because of the curvature. There's a thing called an antipodal point. I'm highlighting that word, antipodal. That means like north and south pole. They are opposite one another on the sphere. There's actually a website, and I meant to link it here, but you can like Google search it, where you can find what point on the Earth is antipodal to where you are. So if you could theoretically tunnel through the middle of the Earth, like where would you end up? Okay, and then when you're finding lines, we have the 2 points there that we're calculating the distance between, like points A and C or A and B or whatever. You have to remember that when we go back to circles and we were calculating distance of arcs, like that's what we're working with here. We need to find what percentage or what fraction of the full circumference of that circle, that globe, it's going to be, and you calculate the distance by calculating it as an arc, as a portion of the circle. Okay, remember, arc distance is 2 times pi times the radius multiplied by the angle out of 360. So it's important to know your angle, or what portion of the circumference that you're having to deal with, and that's how you calculate the distance between those. Your assignment for today, it's this worksheet that I made, but I went ahead, questions number 1, 2, and 3. Questions number 1, 2, and 3 are asking you to draw a sphere, kind of illustrate what's going on with those. So I did download this as a PDF, and I'm going to upload it as a PDF so that you can use Cami and you can just go ahead and draw on that for what you're going to turn in. Good luck.